Okay, we're going to work on this inverse worksheet. I'm going to try to help you follow what I intend for you to understand. So, f of x is y equals x to the third. If that's f of x, f of a, if a is 2, we're trying to find a 2 cubed. So if we put in 2, we get 2 cubed, 8. And what's the slope at 2? Well, the derivative of x to the third is, so dy dx, or y prime, is 3x squared. And so this is how we find the slope, and the slope at 2 is 2 squared is 4 times 3, 12. So the slope is 12 at 2. Okay, now the inverse of this, when you find the inverse, you swap the y and x, so this would be x equal y to the third. This is a trig one, so we're not going to find any. Now I said solve for y in this, and this is the third column. So solve for y. So to get rid of the cube, we do the cube root. So the cube root of x equals y, or x to the 1/3 equals y. Those are the same. Now, to find the derivative of this, we can do the power rule. It would be 1/3 x to the minus 2/3. But so that we can do it for these other ones that are not so obvious, we're going to go through a process that we're going to use on the rest of them here. So find the derivative with respect to x in here. So the derivative of x is 1. And if this was x, the derivative would be 3y to the 3x to the second. But since it's y, we have to say times the derivative of the inside according to the chain rule. So it's going to be 3y to the second, but since that's not x, then we have to say times the derivative of the inside, which is dy dx. And then I want you to solve for dy dx. It's times this, so I'm going to divide by that. So we get 1 over 3y squared is dy dx. So this is the derivative of that, but it has a y, not an x. So we need to solve for that. So I'm going to go back to where we swapped them and put in something for y. So we're going to solve for y in this. So to solve for y, we can take both sides to the 1/3 power, or call it the cube root of x. That's what I'm going to put in place of y. So I get 1 over 3 cubed root of x squared. So that's like x to the 2/3 in the denominator. And if we did the derivative of this, it'd be 1/3 x to the negative 2/3. And negative 2/3 would put it in the denominator. The 1/3 creates a third. So this is the derivative of this according to the power rule. It looks like this. And to check, so I'm going to step aside here for a sec, and I'm going to draw y equals x to the third. So 1 to the third is 1, 2 to the third is 8, 0 to the third is 0, minus 1 to the third is minus 1, minus 2 to the third is minus 8. So that's what x to the third roughly looks like. And if I were to find the slope of a tangent line, say at 8, it's really steep. At 2, I should say. It's 12 over 1, which is what we got right here. It's up 12 over 1. That's how steep that line is. Okay? Now the inverse, the cube root of x, or the inverse, these points reversed. So instead of 1, 1, we switch them, it's still 1, 1. Instead of minus 1, minus 1, it's minus 1, minus 1. That point stays the same, 0, 0 stays the same, but 2, 8 becomes 8, 2. And negative 2, negative 8 becomes negative 8, negative 2. So this is what the inverse looks like. It's a reflection over the y equal x line. This original graph gets flipped that way. So let me draw that one in red. The red is the inverse. Sorry for you that are colorblind. The slope of the tangent here was up 1 for 12, up 12 for 1 at 2, 8. So the slope at 8, 2 is up 1 for 12. So the slope of the inverse at the inverse point, this point was 2, 8. Its slope was 12 over 1. At the inverse point, 8, 2, the slope is 1 over 12. The slope gets flipped when we go to the inverse's corresponding point. So we figured out the slope was 12 at 2. So the inverse's slope at 8 should be 1/12. And we're going to check that right now. So we're going to put 8 into this. So we're going to have 1 over 3 times the cube root of 8 squared. Cube root of 8 is 2, squared is 4, times 3 is 12. So we get 1/12 is the slope at the point 8, 2, 8, 2 on the inverse. The inverse's point is 8, 2, and its slope is 1/12. So that's what's going on here. That's how this inverse works. If you know the slope at 2, 8, the slope at 8, 2 on the inverse function is the reciprocal of this. And we could get this one easy enough by doing the power rule. However, some of these, in fact all of these, you can't use the reverse of the power rule. So now we're going to learn what the derivative of the inverse of e to the x is, or arc sine, or arc cosine, or arc tangent, or arc cosecant, all those. And that's what the whole point of this exercise sheet is. So I'm putting 1 in for x, and so I get, if you put in 1, I get e to the 1, which is e. So the point on the inverse would be e1. Switch the coordinates. So we want to find the slope there. It should be the reciprocal of the slope there. Let's find out what the slope is here. So if we take and find the derivative of e to the x, that is itself e to the x. We learned that. So if we put 1 in for x, we get the slope is e. So over here we should get 1 over e. Let's find out if we do. So it says swap the y and x over here, so we get x equals e to the y. Eventually we're going to have to solve for y, and I don't know how good you are at this, but this is a log thing. The natural log says to what power do you take e to get x, and the answer would be y. This is the inverse. Those are inverse functions. So what we're going to be trying to find is an equation for the derivative of the natural log of x. Okay? Up here we found the derivative of the cube root of x. We found it was this, which is the same thing we got from the power rule here. What is the derivative of natural log of x? We can't do the power rule. So, first thing, solve for y in column 3. We did right here, and that's y equals ln x. Take the no, excuse me. Yeah, y equals ln x. Now we take the derivative of this. The derivative of x is 1. The derivative of e to something other than x, it's e to whatever that something other is, times the derivative in there according to the chain rule, like we did up here. Since that's not an x, we have to go times the derivative of whatever y is with respect to x. Then solving for dy dx, we have to divide by e to the y equals dy dx. And now we're going to replace the y, or actually we know e to the y is x, so 1 over x is dy dx. So this is indicating that the derivative of ln of x is 1 over x. Let's check. The slope at 1 was e, so the slope at e should be 1 over e. We put e into this and we get 1 over e, which is the reciprocal of that. So that checks. All right, now let's try the trigs, which is the main reason for doing these, other than the ln one. These are harder to understand what the derivatives are. So I'm asking you to consider the point pi over 2 and sine of pi over 2. So if I go to my unit circle and go to pi over 2, this side is 1/2, square root of 3 over 2, and 1 if this is pi over 6. And the sine is the opposite over the hypotenuse, so it's 1/2. So what is the slope of the sine curve? Remember, the sine curve looks like something like this. And we want to know the slope at pi over 2. Pi over 2. This is right here. So we're going to go, no, pi over 6, excuse me, pi over 6. Pi over 6 right here. And it's bigger than 0 and less than 1. So, but we're going to find it by finding dy dx, which the derivative of sine is cosine x. So the slope would be the cosine of pi over 6, and the cosine of pi over 6 is square root of 3 over 2. So the slope of the sine curve at pi over 6 is square root of 3 over 2. So the slope of the cosine, the sine inverse or arc sine of x at 1/2 should be 2 over the square root of 3. That's what we're hoping what we come up with will tell us here. So let's go to here. Swap the x and y. So we get x equals sine of y. And now I want to make a picture of a triangle where the sine of y, so this would be the angle, is x over 1, so opposite side to the hypotenuse. This y has a sine of x over 1, or x. And if I use my Pythagorean theorem, x1, and I want to find this side, let's say that's a leg squared plus a leg squared equals the hypotenuse squared. So I subtract x squared from both sides, and I get this leg squared is 1 squared is 1 minus x squared. Take the square root, and I get this side has to be square root of 1 minus x squared. So this side is the square root of 1 minus x squared. That's going to be important down the road here. Now, come back, solve for y. So to get rid of the sine, we do the sine inverse of x equals sine inverse of the sine cancels out equals y, or arc sine of x equals y. Those say the same thing. And all we do is take the sine inverse of this and sine inverse of this side. Sine inverse of this and sine inverse of the sine makes, they cancel each other, and we just leaves the y. So we're trying to find, we tried to find something for the derivative of ln x. We found out it was 1 over x. Now we're trying to find the derivative of sine inverse of x, or arc sine of x, and it should show up here. So take the derivative of this. Derivative of x, again, is 1. Derivative of sine of something is cosine of something times the derivative of the something. And since we don't know what the derivative of it is, all we have to do is say we got to take the derivative of it. We're going to this cosine y is times it. We're going to solve for this, so we're going to divide by cosine y. And then we're going to get rid of the cosine of y by looking at the triangle. See, the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, so it's the square root of 1 minus x squared divided by 1, which would be just the square root of 1 minus x squared. So dy dx is 1 over this. This is the derivative of either one of those. To check, if we put pi over 6 in, we find the slope is square root of 3 over 2. So the inverse, at 1/2, it should have a slope of 2 over the square root of 3. So at 1/2, so I'm going to plug a half into this for x. 1 over square root of 1 minus 1/2 squared. 1 over 1/2 squared is 1/4. 1 minus 1/4 is 3/4. So we get 1 over the square root of 3 divided by the square root of 4, which is 2. 1 over the square root of 3 over 2 is 2 over the square root of 3. The reciprocal of this, which is what it should be. So that's the derivative of sine cosine. This is the derivative of ln. So now let's find out what the derivative of arc cosine. So going through the process, we're now looking at the point pi over 6. And we're going to find the slope there. But first, what is the point? Well, if we put pi over 6 in here, cosine of pi over 6, the cosine of pi over 6 is square root of the adjacent over hypotenuse, so it's square root of 3 over 2. So the slope of this at pi over 6 we're going to find, and it should be the reciprocal of the slope of the inverse at square root of 3 over 2. So derivative of cosine is negative sine, and if I put pi over 6 in there, the sine of pi over 6 was 1/2, and so this is negative 1/2 is the slope on this graph. So its inverse slope should be negative 2 over 1, the reciprocal. Okay. In this column, column 3, we swap y and x. So this becomes x equals cosine y. Now we're going to make a triangle that matches this. So the angle is y. The cosine is adjacent over hypotenuse. And like we did up here with x on a leg and 1 on the hypotenuse, x on a leg, 1 on the hypotenuse, the other leg is 1 minus x squared. You can go back to the video to see how I did this one to get that one. To solve for y in this, we have to get rid of the cosine. So we do cosine inverse of both sides. Or arc cosine of both sides. And so we're going to be trying to find the derivative of the arc cosine down here. To do that, we go back to here, find the derivative. Derivative of x is 1. Derivative of the cosine of y is negative sine y. Since that's not an x, it's times dy dx. Solving for dy dx, Looking at the triangle, the sine is opposite over hypotenuse. So this is 1 over minus square root of 1 minus x squared over 1, which doesn't change anything. So that is the derivative of arc cosine. It looks exactly like the derivative of arc sine, except with a negative. Now let's check. The derivative of cosine was at pi over 6 was negative 1/2. So the derivative of the arc cosine at square root of 3 over 2 should be minus 2, the reciprocal of this. So let's check. We're going to put in square root of 3 over 2 in for the x in this. So I'm going to have 1 over minus square root of 1 minus square root of 3 over 2 squared. Square root of 3 squared is 3, 2 squared is 4. So this is 3/4 from 1 is 1/4. So this is minus 1 over square root of 1/4. The square root of 1/4 is 1/2. So this is minus 1 over 1/2, which is minus 2. If you invert and multiply by 1, 2 over 1, numerator and denominator, which is the reciprocal of minus 1/2. So that checks. Now we're going to do tangent. Tangent of pi over 6 is 1/2 over the opposite over adjacent, 1/2 over the square root of 3 over 2 over 1, or 1 over the square root of 3, the halves cancel. So the arc tangent at 1 over the square root of 3 should have a slope of the reciprocal of the slope here. We're going to find the slope here. See, the derivative of tangent was secant squared x. And so the slope at pi over 6 is secant of pi over 6. So now some of you forgotten this. We had originally sine of x, cosine of an angle, and tangent of an angle. The reciprocal functions were secant x, cosecant x, and cotangent x. One of the three has a co of the original. Two of the three have cos on the inverses, or the reciprocals, not the inverses, the reciprocals. The tangent's reciprocal is cotangent. Tangent didn't have a co, goes with one that does have a co. Sine doesn't have a co. It goes with one that does have a co. So if the sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, the reciprocal. And similarly, cosine has a co, secant doesn't. The ones without cos are paired with cos, and the ones with cos are paired without cos. So if I want to know the secant at pi over 6, secant is paired with cosine. Cosine is square root of 3 over 2 over 1, adjacent over hypotenuse. So the secant is 1 over this. 1 over the square root of 3 over 2 is 2 over the square root of 3. And we're supposed to square that. So this is going to be 2 over the square root of 3 squared, which is 4 thirds. So what this means, on the tangent graph at pi over 6, the slope is 4 thirds. On its inverse, arctangent graph, at 1 over the square root of 3, the slope should be 3/4. All right, swap the y and x. So the inverse is going to be x equals tangent y. Draw a triangle where y is the angle and the tangent's x over 1. Tangents opposite over adjacent. A Pythagorean theorem now says leg squared plus leg squared equals hypotenuse squared. So it's going to be 1 squared plus x squared square root. That's the same as square root of 1 plus x squared, or x squared plus 1. Doesn't matter which way you write them when they're added. We're going to use this when we get to the step down here. But right now, we're going to take the derivative of this, which is going to be 1. No, excuse me, we're going to solve for y in here, we're supposed to do. So y is, to get rid of the tangent, we do tangent inverse of both sides, or y equals arctangent of x. So we're trying to find the derivative of this. That should show up here. By taking the derivative of this, derivative of x is 1, derivative of tangent is secant squared of whatever's in it times the derivative of what's inside it, according to the chain rule. Solve for dy dx, and we get 1 over secant squared y is dy dx. And the 1 over secant squared is, 1 over secant is cosine, so it's cosine squared y. So I'm going to look at the cosine, which is this adjacent over hypotenuse. So the cosine is 1 over square root of 1 plus x squared. And we want to square that. So that becomes 1 squared is 1, and the square root squared just gets rid of the square root, and we get 1 plus x squared, or x squared plus 1. That's the derivative of arctangent. Let's check. At pi over 6, the slope was 4 thirds. At 1 over the square root of 3, the inverse's slope should be 3 over 4. We're going to put 1 over the square root of 3 in for the x's, and we get 1 over 1 plus 1 over the square root of 3 squared. So that's 1 over 1 plus, 1 over the square root of 3 squared is 1 over 3. So 1 plus 1/3 is 4 thirds. So 1 divided by 4 thirds is 3/4, or the reciprocal of 4 thirds. It checks. So this is the derivative of arctangent or tangent inverse. Okay, we only got 3 more to do here. Let's see if we can crank those out. Cosecant is the reciprocal. Cosecant is the reciprocal of sine. So if we want to put in pi over 6, the sine of pi over 6 is 1/2. So the cosecant is 2 over 1. Sine is 1/2 over 1, or 1/2. Cosecant is the hypotenuse over this. 1 over 1/2 is 2. Now, what would be the slope at pi over 6? Well, the derivative of cosecant, we did it in class, is negative cosecant x cotangent x. So if I put in pi over 6, we'll find out the slope of the cosecant curve at pi over 6. So the cosecant is 1 over the sine. The sine of pi over 6 is 1/2 over 1. So 1 over 1/2 over 1. So 1 over 1/2 is 2. So we get negative 2 times cotangent. Tangent's 1 over the square root of 3. So cotangent's square root of 3 over 1, which is just square root of 3. So there's the slope of the cosecant curve at pi over 6. Swap the y and x. X equals cosecant y. This is the inverse of this. Draw a picture. The angle again is y. And cosecant is 1 over sine. So this is saying 1 over the sine of y, or the sine backwards. So instead of opposite over hypotenuse being x, it's hypotenuse over opposite being x. If I do Pythagorean theorem on that, it's going to be hypotenuse squared minus leg squared. So this is going to be x squared minus 1. Okay. Solve for y. So we do cosecant inverse of both sides. Cosecant inverse of x equals y, or arc cosecant of x equals y. We're trying to find the derivative of that. It'll be down here. Take the derivative of this. Derivative of x is 1. Derivative of cosecant, we talked about that in class. That is this. So it's going to be negative cosecant y cotangent y times the derivative of the inside times the derivative of y, which is dy dx. So we divide by this, and we get 1 over negative cosecant y cotangent y is dy over dx. Now, getting these back to x's by looking at the triangle, we get 1 over cosecant. Cosecant's reciprocal of sine. So instead of 1 over x, cosecant is x over 1 minus x, and cotangent. tangent is 1 over this, so cotangent's this over that. So that's square root of x squared minus 1. That's the derivative of this. Now let's check. The derivative of cosecant, the slope of the cosecant at pi over 6 is negative 2 square roots of 3. So at 2, the slope of the inverse should be 1 over that. So we're going to put in 2 into this, and we get 1 over minus x is going to be 2. And then we're going to put in square root of x squared, which is 2 squared, 4, minus 1. And we get 1 over minus 2 times the square root of 3. Which is the reciprocal of this. It checks. So far, just kind of review. The derivative of ln of x is 1 over x. You're not going to have to do this all the time. I'm just trying to help you understand how we come up with these strange things. The derivative of arc sine is 1 over the square root of 1 minus x squared. The derivative of arc cosine is 1 over minus square root of 1 minus x squared. The derivative of arctangent is 1 over 1 plus x squared. The derivative of arc cosecant is 1 over minus x times the square root of x squared minus 1. It's really important that these are reversed. When there's a minus, it's important. On a plus, it's not. And arc secant. So we're going to do secant, which is the reciprocal of cosine. So if we put in pi over 6, cosine of pi over 6 was square root of 3 over 2. So the secant is 1 over the square root of 3 over 2, or 2 over the square root of 3. And now let's find the derivative. Derivative of secant is secant x tangent x. So the secant of pi over 6, secant's reciprocal cosine, so it's 1 over this, so it's 2 over the square root of 3. Times the tangent, and the tangent is 1 over the square root of 3. So that's 2 times 1 is 2, square root of 3 times square root of 3 is 3. So the slope here is 2/3. The slope at pi over 6 of the secant curve is 2/3. So the slope of 2 over the square root of 3 of the arc cosecant should be 3/2. Okay, let's see if we can come up with that. Swap the y and x. And secant is 1 over cosine of y, just in case you need to remember. The triangle. So if this is y, the secant is x over 1, so the cosine is 1 over x. 1 over x, adjacent over hypotenuse, cosine. So this side will be hypotenuse squared minus leg squared. and square root. Solve for y. We do the arc secant or secant inverse of both sides. Or arc secant of x equals y. This is what we're trying to find the derivative of. We take the derivative of this. That's derivative of x is 1. Notice the pattern here. Equals, and the derivative of secant is secant tangent, but it's of y, so secant y tangent y times the derivative of the inside. Since it's not an x, we have to put a dy dx. Solving for dy dx, we divide by the secant y tangent y on both sides. We get 1 over secant y tangent y equals dy dx. And now looking at the triangle, we find that we have 1 over secant, which is just cosine. Cosine is 1 over x. 1 over tangents, so that tangents this over that, so 1 over tangents, 1 over that. And that's dy dx. And since 1 over that times 1 over that is just 1 over those two multiplied, you notice it's the same as the derivative of arc cosecant, except that it's positive instead of negative. So these kind of match. The cosecant has a negative, but it's an x, square root of x squared minus 1. Arc secant's derivative is 1 over x times the square root of x squared minus 1. And if we're finding it at the slope at this point, since the slope at pi over 6 of the original function is 2/3, at this point it should be 3/2 in the inverse. So we're putting 2 over the square root of 3 in for the x. So 1 over 2 over the square root of 3 is square root of 3 over 2. And if I put 2 over the square root of 3 in for the x, I get 1 over square root of 2 squared over the square root of 3 squared. So 4/3 minus 1 is 1/3. Square root of 1/3 is 1 over the square root of 3, and we have 1 over that, which should be square root of 3. We have square root of 3 over 2 times square root of 3, which is 3 over 2, which is the reciprocal of 2/3. So that one checks. So the derivative of arc secant x is 1 over x times the square root of x squared minus 1. Of arc cosecant, it's 1 over minus x times the square root of x squared minus 1. These two are very similar. One of them's minus, one's plus. These two are very similar. One's minus, one's plus. So cotangent, probably very similar to tangent, which was this. Well, let's see what it is, just based on the pattern. So at pi over 6, see, the tangent of pi over 6 is 1 over the square root of 3, so the cotangent's square root of 3 over 1. Derivative of cotangent is is, according to what we found, negative cosecant squared x. So, pi over 6 cosecant, reciprocal of sine. Sine of pi over 6 was 1/2 over 1, so this is 1 over 1/2, or 2. So we got minus 2 squared, which is negative 4. So the slope over here should be minus 1/4. We'll see if we get that. Swap the y and x. I've been writing it the other way. I should have wrote x equals cotangent y. But anyway, make the triangle. Y is the angle. X over 1, cotangent's not opposite or adjacent, but adjacent over opposite, so it's x over 1. And so this side is leg squared plus leg squared square root, and see these both legs, so that's going to be the square root of x squared plus 1, or 1 plus x squared, so that's starting to look like arctangent somehow. Solve for y here, so we get y, and we take the arc cotangent of both sides, so we take cotangent inverse of x equals y, or arc cotangent x equals y. Take the derivative here, and the derivative of x is 1. The derivative of cotangent is negative cosecant squared of whatever was in there, y. Oh, that's not an x, so we have to multiply by dy dx. Solve for dy dx by dividing by that. Cosecant, this is 1 over sine, so this is just negative sine squared y. And sine squared is 1 over that squared, 1 squared over that squared, which is just 1 over x squared plus 1 with a minus. And that is the derivative of cotangent. The derivative of tangent was 1 over 1 plus x squared. The derivative of cotangent is 1 over 1 plus x squared, but negative, just the negative. It's the only thing difference. And let's check. We're supposed to be getting not negative 4, but negative 1/4 when we put square root of 3 in. So let's see. Negative 1 over x squared, square root of 3 squared is 3 plus 1 is negative 1/4. Instead of negative 4, we get a negative 1/4. It checks. So this sheet is to help you understand that y, the derivative of ln x, is 1 over x. The derivative of arc sine y is 1 over the square root of 1 plus x squared. The derivative of arc cosine is the negative of 1 over the square root of 1 minus x squared. The derivative of arc tangent is 1 over 1 plus x squared. The derivative of arc cosecant is 1 over negative x times the square root of x squared minus 1. The derivative of arc secant is 1 over x times the square root of x squared minus 1. And the derivative of arc cotangent x is minus 1 over x squared plus 1. These are the two important columns that I want you to get on your note card. The derivative of this is that. The derivative of either one of those is this. Derivative of either one of those is this. The derivative of either one of those is that. Derivative of either one of those is that. Derivative of either one of those is that. And the derivative of either one of those is that. Okay.